Having trouble answering questions like this one, or maybe this one, then you've come to the right place. Hello there and welcome to my channel. Walter here, and today I'm taking you through the topic circular measure for A-level maths. So I'm going to be taking you through a cheat sheet which I designed, which has all the important concepts you need to make sure that you succeed in this topic. You can download a copy of this document down in the description. So without much further ado, let's get started. Alright, so let's start with the basics, like what you need to know for you to master this topic. Right, the first thing is you need to know how to convert between degrees and radians. Right, so the first thing is the fact that 180 degrees is equal to pi radians. Okay, so when you're doing that conversion, make sure you know that when you're converting between degrees and radians, 180 degrees is equivalent to pi radians. So essentially, if you are going to convert from degrees to radians, then what you do is you multiply by pi over 180 degrees. So for example, if you have something like 720 degrees and you want to convert that to radians, just say whatever value you have in degrees. In this case, we've got 720. Then we're going to multiply that by pi over 180 degrees. And when we do that, we know that 180 goes into 180 once, and into 720 it goes in 4 times, so 4. So basically in radians you will get your answer as being 4 pi. All right, so that's just how you convert from degrees to radians. The second thing is how you convert from radians to degrees. Okay, so how you do that is you simply multiply by 180 over pi. An example here that I have for you is when you want to convert, say, 5 pi over 6 radians to degrees. So we're saying that it's 5 pi over 6, and to convert it, we multiply by 180 degrees, and that's over pi, right? So 6 goes into 6 once, and 6 into 180, that's 30 degrees, right? And the pi's cancel, so 50 times 3 gives us 150. So we get the answer here as being 150 degrees. As simple as that. So these conversions are very important, and you will need to do them along the way as you solve problems involving circular measure. Alright, so there are some common angles, okay, which I expect any A-level student to know how to, like, you just have to know these, the radian equivalent of these angles, right? So we know that 180 degrees is pi radians, right? And we know that 90 degrees is half of 180, so it has to be half pi. We also know that 45 degrees is half of 90 degrees, so that's going to be a quarter pi in radians. 360 is twice 180, right? So it's 2 pi in radians. So these are just common angles you need to know the radian equivalent of. All right, 30 degrees is a sixth pi basically in radians. 60 degrees is a third pi in radians. Then 120 degrees is 2/3 pi, and 150 degrees is 5/6 of pi. So these are some basic angles whose radian equivalent you should just know even from the top of your head. Okay, but if you have forgotten, you can still use the conversions which I've given you. Okay, from degrees to radians, that's you multiply by pi over 180 degrees, and from radians to degrees you multiply by 180 degrees divided by pi. So this is very important. All right, so next we are going on to some common trig ratios which you also need to know, okay, from the top of your head. You don't have to go to the calculator for everything. All right, there's some things that you should know from the top of your head if you're going to maximize your time in the exam. All right, so there are 3 basic angles, all right, whose trig ratio values you should just know. All right, now we have pi over 6 here, which basically is 30 degrees. All right, and sine of 30 is a half. Then tan of 30 is 1 over root 3. Then cosine of 30 is root 3 over 2. So we expect you to know these basic trig ratios, even from the top of your head, without going to the calculator. But if needs be, you can just use your calculator to fetch these results. Then we have a quarter pi, which basically is 45 degrees. And sine of 45 degrees is root 2 over 2, or 1 over root 2. So let's just write it as root 2 over 2. Then tan of 45 degrees is 1. Then cosine of 45 degrees is root 2 over 2. So this is very important, okay, just for you to recall these basic trig values. The next angle is a third pi, which basically is 60 degrees. And sine of 60 is root 3 over 2. Tan 60 is root 3. And cosine of 60 degrees is root 3. Okay, so that's root 3 over 2. So these basic trig ratios are important, and you should just know them. Alright, so now we want to get into another very important thing, okay, when it comes to circular measure, and that is arc length. Alright, so I'd want you to consider a sector of a circle in which the radius r, okay, the radius is r, and we have this angle theta subtended at the center, and we want to find the arc length, which is L here. So we're saying here to find the arc length L of the sector of a circle, we use this formula here. That's L is equal to r theta. And it's important for you to note that well, the radius of the circle is r, and theta is the sector angle in radians. Okay, so theta has to be in radians for you to apply this formula. So you're going to be making use of this formula quite a lot in solving problems involving circular measure. Let's go to the next important thing, alright, and that's areas. Okay, how we find the area. Okay, first of all, we want to see how we can find the area of a sector of a circle. So the formula that we use for that is area is equal to half radius squared theta. So the same conditions apply. Okay, theta should be in radians. Okay, so very important. So that's the formula for the area of a sector. All right. Next up is also the area of a segment of a circle. Okay. Now, when we talk of the segment of a circle, I want you to consider here this sector with radius r and the angle subtended at the center being theta, and well, this shaded region is what we call the segment of the circle. All right, so to find that area, okay, we can say the area of the segment is equal to the area of the sector itself. So we can find the area of the whole sector, and then we subtract the area of the triangle. All right, so we can find the area of the whole sector, and then from it subtract the area of the triangle, and that will leave us with the area of the segment. All right, so this can be expressed as A is equal to, for the area of the sector, we said we find it by half radius squared theta, and that's minus for the area of the triangle. Okay, so this triangle here, to find that area, we can say half side times side, which is r squared, of sine of theta. So basically we're saying the formula is A is equal to half r squared. If we factor out half r squared, open bracket, theta minus sine theta. So I've just factored out half r squared here, and what we now have is the formula for the area of the segment, and I know you will find this quite useful. Alright, so these are the basics, all right? And we still have more, okay? Because besides these formulas, there are other things that relate to circular measure which you just have to know. So let's go to the next concept, okay? The next few things that you also need to know if you're going to master this topic, and these are concepts related to plane trigonometry. Right, so you have to know the basics, okay, basic trigonometry of a triangle in order for you to make sure that you answer properly questions involving circular measure. All right, so we can consider this triangle in which the side C here is the hypotenuse, and this side here is the opposite side because it's opposite the angle, okay? And this side here is the adjacent side. So when we talk of cosine, we basically mean the adjacent side divided by the hypotenuse. All right, so that's how we find cosine. So the adjacent side in this case is B, and it's over C, like we have written here. Then for sine theta, sine is opposite side over hypotenuse basically. So in this particular case, that's going to be opposite side A divided by hypotenuse C. And the last one is tan, which basically is the opposite side divided by the adjacent side. Okay, so in this particular case, that's A over B. So you just have to know this, okay? Very important. And this can be summarized by SOHCAHTOA. I know you know this from your IG, okay? So this is very important. So S stands for sine, so it's opposite of hypotenuse. C stands for cosine, adjacent over hypotenuse, and T stands for tan, that's opposite over adjacent side. So you can make use of this to help you recall these concepts. Next, I also put in these relationships, okay, which we can derive from the basic three trig functions. The fact that if you want to find the side A, which is an opposite side, you say hypotenuse sine theta. So when the hypotenuse is known and you know what the angle theta is, to find the opposite side, which in this case is A, you just say hypotenuse sine the angle. So A is equal to C sine theta. And if you want to find the side B, which basically is the adjacent side, and you know what the hypotenuse is, so you say it's hypotenuse cosine of the angle. So that's basically how you'll be doing it right there, and it's very important you know how to do that. So B is equal to C cos theta. All right, now coupled to these trig ratios, you're also expected to understand Pythagoras theorem, because at times you will be required to apply Pythagoras theorem in the process of solving circular measure problems. So know your Pythagoras theorem. Hypotenuse squared is equal to opposite side squared plus adjacent side squared. So C squared is equal to A squared plus B squared. And another thing related to Pythagoras theorem, which you should just know, are what we call Pythagorean triples, okay? So Pythagorean triples. And with Pythagorean triples, we're saying that if you have your right angle triangle and you know, say, two of the sides, then it has to be easy for you to find the third side because you know the Pythagorean triples. For example, if you have, this is the right angle, right? 3 and 4 for the two sides, then you know automatically that your hypotenuse is going to be a 5. Okay, because these are common Pythagorean triples, 3, 4, 5, which we have here in the first row, right? And for the second row, we know that if you have, say, the hypotenuse being a 10 and one of the sides being an 8, then the third side should be a 6. So these, you know, Pythagorean triples are quite useful. Okay, you can make use of them, especially when you don't want to constantly be going back and forth with your calculator. If you know them by head, it's easy for you to know what the third side is when two of the sides are known. So these Pythagorean triples are worth memorizing. All right, next up, I also want you to make sure you understand complementary angle relations. So we're saying if you have, say, your right angle triangle like this, okay, and one of the angles is theta, and you have your right angle here, then automatically the third angle is going to be half pi minus theta, or 90 minus theta. So it's important for you to know the complementary angle relationships, especially with regards to sine, cosine, and tan. So we're basically saying that if you have sine of 90, which is half pi, minus theta, it's equal to cosine of theta. And if you have cosine of half pi minus theta, it's equivalent to sine theta. And tan of 90 degrees, which is half pi, minus theta is the same as 1 over tan of theta. So these complementary angle relationships are very important, okay? You'll find that if you understand these basic relationships, you will find it easy solving many problems, all right, as you're going to see. So you need to make sure that you master these relationships. Let's go on to the next important thing, and this is the concept of the sine rule and the cosine rule. Now we expect that you have already done the sine rule and the cosine rule from your IGCSE maths. Okay, so I have the formulas laid out here for you to recall. For the sine rule, basically you have to know an angle and its opposite side. If one angle is known and its opposite side known on a triangle, then the sine rule will be most applicable. All right, and when it comes to the cosine rule, basically what you need is two known sides and an included angle for the most part. So it mainly works with two adjacent sides and an angle in between. That's how the cosine rule works. But we're not going to get much into these concepts because I believe you already have an idea from your IGCSE on what the sine rule is and what the cosine rule is. But I want you to understand that you will need to use these formulas at some point when you're solving problems involving circular measure. Let's move on to finding the area, okay? Area of a triangle, right? So when the height is known, okay, height known, then you can use half base times height. But when the height, okay, is unknown, but you have other things like two adjacent sides, A and B, and the included angle, then it can be wise that you use half AB sine theta. So very important things you have to understand right here. Right, let's go on to the next page. So some other things that you will find useful when you're solving problems involving circular measure are your circle theorems. All right, so you have to know the basic circle theorems. I have listed here only 3, but you know from your IGCSE that there are many other circle theorems which you need to which you might need to use, but these ones are the ones that you mostly find in problems involving circular measure. The first one is the fact that the angle in a semicircle is a right angle. So if you have a semicircle, okay, and there's an angle subtended to the circumference, then you need to know that that angle is going to be a right angle. The second one is that the angle between the tangent and the radius at the point where the tangent touches the circle, it has to be a right angle. All right, so that's another very important circle theorem. And the third one is the fact that two tangents, okay, two tangents drawn from a point to a circle are equal. So basically we are saying that if this, say, is a point A and this is a point P and this is a point Q, then AP is always equal to AQ. That's what we're saying here. So these two are equal. All right. And another thing for you to, well, which I think is also important, is if we have an angle here subtended, okay, at the center, which is theta in this particular situation, then with this other angle here, they are going to be supplementary. So this should be pi minus theta. So that's the relationship between those two angles. They add up to 180 degrees. And that's logical, considering that here we also have a right angle. Here we have a right angle. So those two opposite angles are right angles. They add up to 180. So the other two should also add up to 180, since it's a quadrilateral, and all the angles should then add up to 180 degrees. So that's those are very important concepts you also need to use. All right. So now let's look at a few examples. All right. We're going to start with this question here, which says, in the diagram, AB is an arc of a circle, center O and radius 6 centimeters, and angle AOB is a third pi radians. The line AX is a tangent to the circle at A, and OBX is a straight line. So in part 1, show that the exact length of AX is 6√3 centimeters. Alright, so let's answer that. Alright, so we're saying here on part 1, they want us to find the exact length of AX, and AX is this length here. Okay, and to find that, we're considering the whole triangle OAX, and we can use tan. So I'm going to say here tan of the angle at third pi is equal to the opposite side AX over the adjacent side, which is 6, which therefore means that AX is equal to 6 tan of a third pi. Now tan of a third pi, all right, if you go back to these relationships, okay, tan of a third pi is √3. All right, so we're going to say here the answer should be 6√3, and that's how we do it. Okay, let's go on to part 2 of the question. On part 2, they say find in terms of pi and √3 the area of the shaded region. Okay, so to find the area of the shaded region, we're going to say that it's equal to the area of the whole triangle. So let me put it this way, the area of triangle, and that's triangle OAX, right? So OAX, and that's minus the area of sector, and that's the sector OAB, right? So that's how we're going to find the shaded region, right? So for the area of OAX, right, we're going to use, well, half times the base times the height, because we have got two perpendicular sides. All you need for half base times height is two perpendicular sides on your triangle, like these two sides in red. So we're going to say that's half times the base, we'll use that to be 6, times AX, which we got to be 6√3, and that's going to be minus the area of the sector. Remember, area of sector we said is calculated half r squared theta. So here we are saying that it's half times the radius squared, which is 6, times the angle at third pi. Right, so simplifying here, 2 goes into 2 once, into 6, 3 times 6 times 3, that's 18. So we have 18√3, and that's minus half of 6 squared, which is 18 divided by 3 is 6, so 6 pi. So that's the answer right there. Let's go on to part 3. Okay, so let's do part 3 on here. So in part 3, they say we should find the perimeter of the shaded region. So the perimeter of the shaded region involves the arc AB plus the length of AX plus the length of BX. Right, so for the arc AB, remember arc length is r theta. So it's 6 times the angle, which is a third pi, and that's plus, for AX, we've already calculated that to be 6√3, And now for bx, we first have to find OX. Okay, we first have to find the hypotenuse, OX. And since we know that this side is 6 root 3, we can use Pythagoras to find that, to find OX. So we'll say it's the square root of, and that's 6 squared plus 6 root 3. So it's 6 root 3 squared, and that's minus OB, which is 6 centimeters. So that's how we're going to find BX. We'll say the whole OX minus OB, and we're left with BX. Alright, so this is going to be, here we get 2 pi, and for 6 root 3, that's just 6 root 3, and that's going to be plus, and simplifying this other part. So this should actually give us the square root of 144 when we simplify it. So we have the square root of 144 minus 6. Now the square root of 144 is 12, and 12 minus 6 is 6. So the final answer should be 2 pi, and that's plus 6 root 3, and that's plus 6. And that's the final answer right here. So that's how we do it for this particular question. Let's move on to the second example. So it says the diagram shows a circle with center O, alright, and radius 3 centimeters. The radii OP and OQ are extended to S and R respectively, so that ORS is a sector of a circle with center O. So given that PS is equal to 6 centimeters and that the area of the shaded region is equal to the area of C, on part 1, show that POQ is equal to 1/4 pi radians. Right, so the best way to answer these questions is to make use of the statement they would have given you, okay, because they've told us something very important. They've told us that the area of the shaded region is equal to the area of the circle C. Area shaded is equal to area of circle C. Alright, so the shaded area, how do we find the shaded area? Now to find the shaded area, we are going to say that it's the area of the sector, the whole sector, ORS, okay, which is half times the radius of ORS. The radius of ORS is this one here. It's 3 plus 6 basically, so that's 9, right? So we'll say it's half times 9 squared. So half r squared theta. So the angle is theta here. So theta minus the area of the smaller sector, which is half, times the radius, which is 3 squared of the angle theta. That's equal to the area of circle C. Now the area of circle C is basically pi radians squared. So that's pi times 3 squared. So basically that, right? So that's going to be here. I'll factor out half theta, and I'll have 9 squared, which is 81, minus 9, and I have here 9 pi. So 81 minus 9 is 72. Half of 72 is 36. So we have 36 theta being equal to 9 pi. Divide both sides by 36. We'll be having theta being equal to 9 over 36 of pi, basically. So 9 over 36 of pi. And 9 over 36 of pi is 1/4 pi. So the answer is 1/4 pi. So that's how we do it for this particular question. Let's go on to part 2. Okay, so on part 2, they're asking us for the perimeter of the shaded region. Right, so for the perimeter of the shaded region, which is P, I will say it is equal to, we've got for that perimeter, we have this arc here. Then we have this length. Okay, let me draw it properly. So we have this length, and we also have this length, and we have this arc, right? So we have two 6 centimeter sides, so 6 plus 6, then two arcs. The first one is r theta, so it's 3 of theta, and the other one is going to be radius 9, so 9 theta. So we basically have 12 plus 12 theta, but remember theta is a quarter pi, so it's going to be 12 plus 12 times a quarter pi, and we get 12 plus 3 pi for the final answer. So that's how we find the perimeter of the shaded region. Let's go to the very last question, example 3, and it says, in the diagram, OADC is a sector of a circle, center O and radius 3 centimeters. AB and CB are tangents to the circle, and angle ABC is equal to a third pi radians. Find, giving your answer in terms of root 3 and pi on part 1, the perimeter of the shaded region. Alright, so here, for the perimeter of the shaded region, we're going to say that that perimeter is equal to BC plus AB, and that's going to be plus the arc, and that's the arc ADC. So that's basically how we find that. So we're now saying here for BC, all right, if you consider this shape here, you can see that we can draw a line that goes through, okay, and it will bisect the angle. So since it was a third pi, we can say that it has been bisected to a sixth pi and also a sixth pi down here. All right, so if we consider here this triangle with BC and CD here, where we know that this is 3 centimeters by symmetry, so we can find BC, right? We can know what BC is by simply saying that for BC, tan of a sixth pi is equal to 3 over BC. So BC is equal to 3 over tan of a sixth pi. So that's what we're going to be working with for BC. And BC is equal to AB. So for our working, we'll just say 2, 3 over tan a sixth pi's. So this represents BC and AB. All right, and that's plus for the arc ADC. All right, so to find that arc ADC, okay, let me erase this. Okay, to find the arc ADC, we can use the property that this angle here and the third pi radian angle are supplementary. Okay, they add up to 180 degrees. So it means that this angle here should be pi minus a third pi, which makes it 2/3 pi. All right, so to get the arc ADC, we just say r theta, the radius we're working with in this particular case is the radius OA or OC. All right, so we'll just say here it's the radius 3 times the angle 2/3 pi. All right, so this is going to be 2 times 3 over tan of a sixth pi is 1 over root 3. So this should just give us 3 root 3, and that's plus, here they cancel, so we have 2 pi. So we essentially have 6 root 3 plus 2 pi for the answer. So now for part 2, they're saying we should find the area of the shaded region. All right, so for the area of the shaded region, all right, so I'm going to say the area of the shaded region is equal to, we can say the area of the whole shape. Okay, so that's the area of OA BC, and that's going to be minus the area of sector. So take the sector or ADC. So OADC. The area is equal to, now for the area of the whole shape, okay, the whole kite shape we have here, we are going to consider that it's made up of two triangles, all right? And you can see that this angle is a sixth pi because it's half of a third pi. And we also know that the side BC is 3 root 3. We had actually found it to be 3 root 3 earlier. And this side is 3 centimeters. So if we do half base times height, we can actually find the area of that triangle and multiply by 2, and it will give us the area of the whole OABC. So we're saying here it's 2 times half times the base, which is 3, times the height, which is 3 root 3. All right, and that's going to be minus, and for the area of the sector or ADC, we will simply say that's half times the radius squared, which is 3 squared, times the angle, which is 2/3 pi essentially. So it's 2/3 pi. All right, so this is going to be equal to, here they'll cancel. So we have 9 root 3 minus, here we'll be having this 2 divided into this 2. Then basically that's 3 pi we'll get right there. So I'm getting here 9 root 3 minus 3 pi. That's the area of the shaded region. And that's how we do it.